Assalamualaikum and hi everyone. In this video, we will discuss about experiment 3, which is measuring gravitational acceleration for PHY110. In this experiment, we will explain about objectives, theory, apparatus, procedure, results, analysis, and conclusion. Objectives for this experiment are to investigate the functional relationship between height of fall and falling time. Also, to determine the acceleration due to gravity by studying the motion of a freely falling body.
Start with the theory. When a body mass m is accelerated from rest in the constant gravitational field, it moves in a straight line by arranging the coordinate system so that the x-axis indicates the direction of motion and solving the corresponding one-dimensional equation of motion. For the initial conditions, we obtain the time-dependent coordinate h. The h is proportional to the square of the time. A representation of h, t2, can demonstrate this with regression line because the slope is equal to half gravity according to the equation.
The apparatus that we use in this experiment are release unit, impact switch, digital counter, 4 decades, support base, right angle clamp, plate holder, meter scale, support rod, connecting cord, and ball bearing.
Now let's move to the procedure. First, the apparatus set up as in the figure 3.1, grip an electricity conducting sphere in the release mechanism, which closes to the start circuit. Second, the pin was adjusted by using the adjusting screw under the arrest switch in such a way that a downward motion of a few tenths of a millimeter closes to the stop circuit. The pin were raised by the hand after each single measurement, which is initial position. And lastly, for the effectiveness determination of the height of fall on the release mechanism, mark was used. The radius of the sphere was taken into the account, which is diameter 3/4 inch, approximately 90 mm. The aerodynamic drag to the sphere being disregarded.
So these are results that we get when we use a different height. We repeated this experiment 3 times and we found that the t average was sum of the total time taken divided by 3. After that, we found t square by power of 2 the t average. The unit of time is a second.
So, this is our analysis. From the data that we got, then we plot the graph. First graph is height of fall as a function of falling time. Based on the graph, it shows that the height of the fall increases time. This is our second graph, which is height of fall as a function of the square of falling time. Based on the graph, it shows that the height of the fall is directly proportional with square of falling time. From the second graph, we must determine the gradient or slope of the graph and calculate the value of g. First, the formula of the gradient is m equals to y2 minus y1 over x2 minus x1, and the answer that we got is 5 meter per second square. For calculate the value of g, the formula is g equals to 2s over t square, and the answer that we got is 10 meter per second square. The next step is we have to calculate the value of uncertainties of g. The formula is g equals to g standard minus g experiment, and what we got is plus minus 0.19. The last step is we have to calculate the percent error in this experiment. The formula of the percent error is percent error equals to error minus theoretical over theoretical and times with 100%. And the result that we got is negative 98.06%.
The experimental error that can happen in this experiment is a random error, such as parallax error from reading the height of a fall. The parallax error makes the results inaccurate. To avoid this problem, we must make sure that while observing our eyes are perpendicular to the ruler, to decrease the error in the results by repeating the experiment. Also, the ball will not definitely go down the center of each light gate. It is critical to ensure that the apparatus is fully assembled in accordance with figure 3.1 of the lab manual. It can avoid any incorrect analysis. In conclusion, we have investigated the functional relationship between height of fall and falling time. Then, we have determined the acceleration due to gravity by studying the motion of a freely falling body.
That's all for experiment 3.
Now, let's move on to the experiment 5, which is frictional force.
First, I would like to explain about the theory. Force and velocity are vector quantities that have both magnitude and direction. Velocity is the speed in a specified direction with which a given object is traveling. Force exists when the object accelerates or undergoes a change in its velocity. A body at rest or in equilibrium exhibits resultant force, or the sum of all forces acting on the body is zero. Gravity is an attractive force that exists between two masses. The magnitude of the force depends on the magnitude of the masses. The gravitational force that acts on object on Earth is approximately. We have formula Fg equal to mg, where m is the mass of the object and g is the gravitational acceleration. The magnitude of the gravitational force exerted on an object is referred to as its weight. Normal force is a contact force that acts in the normal direction or perpendicular to contact surface between two objects. Figure 5.1 shows the free body diagram of a mass M laying on horizontal surface where the normal end is equal in magnitude to the gravitational force mg. From the free body diagram, the mass laying on a horizontal surface, the direction of weight or mg always downward, and the normal force n is perpendicular to surface. So, next is friction. Friction is the force that resists the relative motion of one surface in contact with another. There are two types of friction, which is static and kinetic. Static friction is the friction that acts on an object that is at rest. Static friction is the force that must be overcome in order to move a static object. The maximum value of static frictional force is given by Fs max equal to mu Sn, where mu s is the coefficient of static friction and n is the normal force. The coefficient of static friction is dimensionless contact that depends on the object and the surface it is laying upon. Kinetic friction is the friction that acts on a moving object that the kinetic frictional force is given by Fk is equal to mu k n, where mu k is the coefficient of kinetic friction and n is the normal force. In this experiment, the frictional force between a wooden block and the rubber surface on a horizontal surface will be measured, and from the plotted data, the coefficients of static friction will be obtained.
The objective of this experiment is to determine the coefficient of static friction of different surfaces.
For our hypothesis, the rougher the surface of an object, the higher the frictional force.
The apparatus that we need to have is wooden block with rubber covered at the one side, 50 gram masses, 10 Newton string scale, string and tabletop.
Procedure of the experiment is, firstly measure the mass of wooden block and record it as m. Set up the apparatus as shown in above. The tabletop have to be stable and horizontal. Attach the spring scale and wooden block with a spring. Put them horizontally on the tabletop. Make sure the rubber side of the block is face downwards. Place a m equal to 50 gram mass on the wooden block. Pull the spring slowly. Once the block starts to move, record the spring scale's reading. Record the value as Fs. Repeat step 4 until 5 for 3 trials. Add another 50 gram mass on the wooden block and repeat step 5 to 6. Repeat the steps until total of m equal to 500 gram mass is on the wooden block.
Based on the table that we obtained from the experiment, it is noticeable that for wooden blocks with rubber surfaces facing the floor, the average static friction forces will increase as well as the mass and total weight of the block. For wooden blocks with non-rubber surfaces facing the floor, the average static friction will increase when the mass and the total weight of the block are increased too. But because the wooden block moves more quickly with its non-rubber surfaces towards the floor, its static friction is smaller compared to the wooden block with rubber surfaces facing the floor.
Here is a free body diagram of the wooden block. The force that acting on the wooden block is 1. Applied force. Applied force is a force which is applied to an object by another object. 2. Normal force. Normal force is the force exerted on the object that is perpendicular to the surface of contact. 3. Frictional force. Frictional force is the retarding force that resists motion of object that is in contact with the surface. And the last one is weight. Weight is the force exerted on an object due to the attraction of gravity. Both of the graphs that we get from the data is a straight line passes through the origin, which means the normal force is directly proportional with static friction force. From the graph, we know that the coefficient of the static friction for rubber surface is 0.00066, while for the non-rubber surface is 0.00028. The coefficient of static friction for rubber surface is 0.00066, while coefficient of static friction for non-rubber surface is 0.00028. Based on the data obtained, the results shown that the coefficient of static friction for the rubber surface is higher than coefficient of static friction for non-rubber surface. The reason for the differences is the rougher surface can produce large frictional force. Therefore, the rougher the surface in the contact, the greater the frictional force.
Now we will discuss about the questions. For the first question, how can anti-lock brakes stop a car in a shorter distance than regular brakes? Anti-lock brakes can stop a car in shorter distance than regular brakes. When we stop the car in the shorter distance, we need a higher friction force to stop the car. The regular brake will lock the wheels of the car. This will cause the wheels to lose traction with the road and will simply slide due to continuing the motion that has already started. By using the anti-lock brakes, it didn't make the car wheels lock and slide when the driver presses the brakes hard. For the second question, from your experiment, which material has the highest coefficient of static friction? Does this agree with your hypothesis? What do you think determines the coefficient of static friction? Rubber surface have the highest coefficient of static friction. Yes, this does agree with our hypothesis. The rougher the surface of an object, the higher the frictional force. The smooth surface of the floor determines the coefficient of static friction. Hence, it keeps the object to be in static friction force.
The third question is, once the mass begins to slide, does it move smoothly or does it undergo stop and go motion? Explain the motion. It moves smoothly when the mass starts to slide. Then it undergoes stop and go movement on both surfaces. The meaning is that static friction resists the pull force. We end up the force that resists any kind of sliding movement and its strength depends partly on what materials are sliding against each other. Rougher material have more surfaces to catch on each other, which is why the block will be easier to slide on the non-rubber surface than if we try it on rubber surface. Secondly, another factor that works in friction depends on how hard the material are pressed together, puts more of their surfaces in contact with each other, thus resulting in the stop and go motion. Conclusion. In conclusion, the factor of mass, surface and inclination give the effect to the friction. The larger the mass applied, will cause the static and kinetic friction force to increase. Moreover, the rougher the surface, the higher the frictional force. Other than that, putting the block on an inclined plane will also increase the frictional force. Therefore, coefficient of static friction are higher with the rubber on. That's all from us. Thank you for watching.